Hello, my name is Patrick Olson, and this is my computational thinking final project. I've chosen the subject of skyscrapers as I'm a building construction major and am fascinated in structures. Skyscrapers are a sign of urbanization and development. Generally, places that have an influx of people and money need tall buildings. This is how population increase also plays a part in analyzing this data. Construction is also one of the top grossing industries of the year, as places are ever evolving. Last year, an estimated 200,000 jobs were needed to be filled in the construction industry alone, and with the average worker being around the age of 55, this number will only increase. With all this being said, analyzing the height of the building and what materials go into the building can help engineers create new and better ways to build bigger and taller buildings. To begin, we must first abstract this information data set so that we can break down the real-world phenomena of skyscrapers into useful numbers. First, we can abstract city as a string, helping us to localize and minimize the location for our information. Next, we can abstract materials as a string as well, and this can help to organize buildings based off of what their main structural materials are for structure and support. After materials, we can abstract country, again as a string, and again helping to localize and minimize the location of our dataset, but certainly not as small as a city. Lastly, we can abstract height as a float value. This is to help us analyze the relationship between height of the buildings and later on in the report. As you can see, the data structure map for skyscrapers is a very extensive one. As seen, there are several dictionaries that associate with several different lists. For my project, I accessed the materials dictionary and chose to use the country and city lists. Likewise, I utilized the statistics dictionary to access the lists of heights. These were the mapping of my decisions I had to code in order to accomplish and complete the tasks. As with any abstraction, there will be limitations to what you can find and analyze. For this specific dataset, I ran into a few when trying to establish how I was going to utilize this dataset. To start, the method of sorting the structural building materials is a little vague and does not use construction terms in the sense that it should. It labels 5 different methods of construction, 2 of them being concrete/steel and then steel/concrete. Secondly, there is no exact definition of a skyscraper in terms of height given in this dataset. Technically, in the construction industry, this definition is set as a building that measures 100 meters or taller. This can be a flexible definition, so again, there could be some discrepancies on smaller buildings as to whether they meet this criteria or not. One last limitation that I encountered was the dataset does not include or account for the cost of the building. Neither the cost to build, operate, or purchase are labeled. So this limits what you can do in regards to this dataset. Now, is there a relationship between the height of a building and the materials used to construct that building? This is the question I wanted to analyze using the skyscraper dataset. In answering this question, we can help to analyze effective building materials for tall and sturdy buildings, as well as see where our trends in construction come when we use materials. For my first set of visualizations, I wanted to analyze 2 things. First, the histogram on the right shows the distribution of heights of skyscrapers, with the height being on the x-axis and the number of buildings at those heights on the y-axis. The second visualization is a horizontal bar chart that shows the total number of buildings constructed out of different structural materials. As you can see with the histogram on the left, there are a lot of buildings that are around 100 meters, and even fewer as the height increases. Using this information, we look over at the materials used to construct these same buildings, and we see that the majority of these buildings are being constructed out of concrete. This could mean that the other materials that are used less frequently because they're only needed in taller buildings, or the materials are more expensive. In analyzing this, we can try and comprehend this data in ways to make it useful. To start, if we know concrete is the most used substance in the constructing of skyscrapers, wouldn't it be efficient to try and come up with a process to produce concrete cheaper and more efficiently? This is just one of the many questions you can try and ask. However, when analyzing data, it is good to look at more than just one instance or location. For my second set of visualizations, I narrowed my search down to just New York City. This is due to the large amount of tall buildings in this area. I wanted to see if my trend from the previous graphs was still present. Like the last set of visualizations, the histogram on the left is the total number of buildings for a given height range, and the bar chart on the right is the number of buildings that used a certain structural building material. In the previous analysis, I noticed that the majority of buildings in the US are on the smaller side of the skyscraper scale, being around 100 meters, and because of that, the majority of the structural elements are concrete. Upon analyzing the data, I concluded that this is a relatively cheap material and can withstand building loads up to a certain height. As you can see in the histogram on the left for building heights in New York City, the majority of buildings are around 150 to 200 meters, with much smaller deviations of numbers from other building heights. The materials bar chart reveals that roughly equal amounts of structures use concrete to build as steel. The relationship analyzed in the previous set of visualizations still holds true for these visualizations as well. Steel is used more frequently as buildings get taller and structures need more support. Knowing this can help influence iron mill companies as to where they should have locations and promote the invention of cheaper and stronger alternatives to steel structures, to name a few. As for any abstraction, there will be people that are involved or affected with the real-world phenomena you're analyzing. In analyzing skyscrapers, the stakeholders could be a variety of different people. A few of the stakeholders that could be involved include the general contracting companies that build these buildings, the building occupants, the building owners, banks and finance companies, the construction laborers, and building material manufacturers. One of the main reasons you name the stakeholders is to see if there will potentially be any conflicts amongst them. For my project, I analyzed a few conflicts that could be prevalent. First, there could be a conflict between the building occupants and the building owner. The owner should do everything he can to ensure a comfortable and safe living environment while providing the building tenants with the quality of building they are paying for. The owner should not try and cut corners for self-gain. Another conflict that could possibly arise would be between the general contractors and the construction laborers. In completing the building, the GCs should ensure the structure is properly assembled and that the laborers are not cutting corners on materials to earn more money. All of this data can be used to help reform and improve the industry, from efficiency to material waste to safer working environments. As per the Honor Code, I have neither given nor received unauthorized assistance on this assignment.